Hello friends, Mr. Burrell here. We're at the very end of our unit on probability. We've talked about set notation, how we write these different types of sets. We've talked about probability, what probability means. We've talked about finding probabilities using a two-way frequency table. In this last concept that we're going to discuss, we're going to continue talking about two-way tables and reading them. We're going to talk about conditional probabilities. What is a conditional probability and how we find a conditional probability. So by the end of this video, this is what I hope you're able to understand. I hope you're able to find a conditional probability using a two-way frequency table. And again, we'll talk about what a conditional probability is and how you find it. And then I hope that you're able to find a conditional probability just given sets and subsets, kind of the notation that we've discussed before we talked about frequency tables. I hope you're able to find conditional probabilities of those types of sets as well. Okay, so let's get into it. So here is the table of values that we talked about when we were talking about two-way frequency tables. This is the, pretend that we did this activity in class. This is what our class set of data would be of different colored M&Ms and different colored Skittles that everybody had. So just again as a reminder, each column represents the number of different colored candies. So there's red candies, orange candies, yellow candies, etc., etc. Each row is the number of M&Ms in those categories, the number of Skittles in those categories. So this is the total number of M&Ms, the total number of Skittles, the total number of red, orange, yellow, and every other color of candy. And then this 562 is the total number of candies all put together in my big bag of Skittles and M&Ms. Okay, so, and again, this is in your guided notes. If you have those printed off, you can follow along. If not, just follow along with me in your notebook or whatever. But it says, imagine your friend chooses a candy piece from the class mix, this giant selection of candy. Imagine that your friend chooses a candy piece from the class mix. She looks at it, tells you that it is red, but doesn't tell you if it is an M&M or a Skittle. So your friend chooses a piece of candy out of the bag, and it's red. It's a red M&M. So knowing that your friend has a red candy in her hand, we can find the probability that it is a red M&M. This is called the conditional probability of an event. This is supposed to be event, not even, because we already know something, a condition about the event in question. So this is going to get us talking about conditional probabilities. We already know that the candy is red because I told you that. My friend pulled out a candy out of the bag. She knows it's red, but she hasn't told us if it's an M&M or a Skittle. So knowing, given that it's red, I can find the probability that that candy is an M&M. Okay, so we're going to answer these questions to help us kind of learn about conditional probability, understand it a little bit more. Let me move my face out of the way here. Okay, so this first question says, what is the total number of possible outcomes for your friend's candy? So again, I circled this column. This is the red column. So remember that my friend, call her, I don't know, Stacy. My friend Stacy drew out a piece of candy. I know it's red. So there's only 78 possible ways that she could have drawn a red M&M, or a red candy, right? Because there are only 78 red candies. So the total number of possible outcomes for my friend's candy, for my friend Stacy, is 78. Because since I know the candy is red, there are only 78 red candies. Okay, part B here says, what is the probability of your friend having an M&M if we know the candy is red? Well, if I know the candy is red, well, there's only 51 M&Ms that are red, right? So the probability of my friend having an M&M, if that candy is red, is 51, because there's 51 red M&Ms, divided by 78 total red M&Ms. So the probability of selecting an M&M, given that we already know the candy is red, is 51 divided by 78, which written as a percentage would be 65.4%, or 0.654. So if I already know the candy is red, the probability of selecting an M&M is 51 out of 78. 51 red M&Ms divided by 78 total red candies. Let's compare that to what the probability of selecting a red M&M is in the first place. So if I just, out of my big tub, selected, I wanted to find the probability of selecting a red M&M out of a total of 562 M&Ms, that would be 51 divided by 562. 51 divided by 562, 562 is 0.091 or 9.1%. So if I have my giant tub with all my different colored M&Ms, all my different colored Skittles, and I wanted to find the probability of drawing a red M&M, it would be 51 out of 562, because there's 562 total candies, 51 red M&Ms. But let's say that I only took out all of the red candies. So now I have this separate tub over here with only red candies, and I wanted to find the probability of drawing a red M&M. Well, now I only have 78 total red candies in this little separate bin over here, 78 red candies. So the probability of drawing a red M&M out of that tub is 51 out of 78. That's a conditional probability. I'm putting a condition on my probability. In this case, the condition was I'm only finding the probability out of these red M&M, or these red candies. Take out all my red candies. That's my new set of total possible outcomes. There's only 78 possible red outcomes, and I find the probability from there. That's a conditional probability. So then here is the last question here to kind of help us understand conditional probabilities. It says, in your own words, explain how to compute conditional probabilities given a two-way frequency table. So in this case, I wanted you to find the probability of selecting a red M&M given the candy was red. So in here, if I'm given that the candy is red, Stacy drew out a red candy, then I'm going to be looking at the red candy column. So given that the candy is red, I'm going to be using my probability formula using this number, 78, as my total number of possible outcomes. Say I had said that Stacy drew out an M&M, and we wanted to find the probability that it was a red M&M. So then I'd be looking at this row with just the M&Ms. I'd imagine that I had just taken out all the M&Ms and put them in a separate vat. There's 266 M&Ms, and I want to find the probability that given the candy is an M&M, what is the probability that that candy is red? So that would be 51 out of 266. So that's how we find conditional probabilities. So let's look at some examples. If this is still a little bit unclear, let's look at some examples, see if we can get this down a little bit more packed. So this is number 5 in your guided notes. It says computing conditional probabilities. Using the class data about the candy mix, find the following conditional probabilities. So in probability notation, a conditional probability is going to be written like this. Probability of, for example, green, probability of green, and then this little vertical bar is read given. So this statement right here would be read, the probability of selecting a green candy given that the candy is a Skittle. So that's my condition. I know that the candy is a Skittle, so given the candy is a Skittle, what is the probability of selecting a green candy? So on this first example, the probability of a green Skittle, or a green candy, given that the candy is a Skittle, I'm going to look only at my Skittle row. Because my condition, I'm giving you the information that the candy is a Skittle. So of my Skittles, what is the probability of selecting a green candy? Okay, well, in my Skittle group, there's 296 total Skittles. I want to find the probability of selecting a green candy out of those Skittles. So there's 52 green Skittles. So 52 divided by 296 would give me the probability of selecting a green candy given that the candy is a Skittle. So 52 divided by 296, that's 0.176 or 17.6%. So given that my candy is a Skittle, there's a 17.6% chance that I will draw a green candy. Okay, next here I have the probability of an M&M given blue. So what's the probability of drawing an M&M given that the candy is blue. So the condition, what I'm giving you, what I'm telling you, what I'm giving you to draw out of is only my blue candies. That's on the right side of this bar. That's what I'm giving you. That's the total possibilities. So given that the candy is blue, what's the probability of drawing an M&M? Well, there are 45 blue M&Ms out of a total of 108 blue candies. So 45 divided by 108 is 0.417, or 41.7%. So the probability of drawing an M&M, given that the candy is blue, is 41.7%. C says the probability of brown given M&M. So I'm giving you the knowledge that it's an M&M, so I know that it's an M&M. What's the probability of drawing a brown candy, given that that candy is an M&M? Well, there's 62 brown M&Ms out of a total of 266 M&Ms. So 62 divided by 266 is 0.233, or 23.3%. And then this last one, the probability of a Skittle given that the candy is red. So again, since I'm giving you the information that the candy is red, I'm only looking at the red column, the red candies. So out of a total of 78 candies, 78 red candies, 27 of those are Skittles. So the probability of drawing a Skittle, given that the candy is red, is 27 divided by 78, which is 0.346, or 34.6%. So about a 34.6% chance of drawing a Skittle, given that the candy is red. Okay, we'll do one or two more of these real quick. I want to do F and I want to do G. So F says the probability of selecting an M&M given that the candy is purple. So I'm giving you the information that the candy is purple, so I'm only looking at the purple candies. I'm only looking at the purple column. So out of a total of 37 purple candies, how many of them are M&Ms? Well, 0. They don't even make purple M&Ms. So the probability of drawing an M&M, if I know the candy is purple, if I'm given the candy is purple, is 0. There's a 0% chance of drawing a purple M&M, drawing an M&M given that the candy is purple, because there are no purple M&Ms. Here says the probability of yellow given M&M. So if I'm given the fact that the candy is an M&M, out of my 266 M&Ms, how many of them are yellow? Well, 40. So the probability of selecting a yellow candy, given that it's an M&M, is 40 out of 266. 40 divided by 266 is 0.150, or 15%. There's a 15% chance of drawing a yellow candy, given that the candy is an M&M. So those are conditional probabilities using a two-way table. I identify what I'm given. So if I, for example, in this situation, when I was asked to find the probability of finding a yellow candy given an M&M, I'm only looking at the M&M candies. I'm only looking at my M&M section. So my new total number of possible outcomes is 266, because I'm only looking at M&Ms. And then I find the probability of selecting a yellow candy in that category, in the M&M category. That's what we're talking about with conditional probabilities. Okay, what if I don't have a two-way table? What is the situation when I don't have a two-way table? Well, let's find out. So on your guided notes, this is number 6. It says a box contains 3 blue marbles, 5 red marbles, and 4 white marbles. So really quickly, I have 1, 2, 3, 4, 5 red marbles. Let's change my color. I have 1, 2, 3, 4 white marbles, and then I have what? 3 blue marbles. 1, 2, 3 blue marbles. So that's my set. That's my set of all possible outcomes. I have a box with 3 blue marbles, 5 red marbles, and 4 white marbles. So that's what I'm working with here. Okay, so again, my sample space, sorry, I should have used that term earlier. My sample space of all possible outcomes is 5 red marbles, 4 white marbles, 3 blue marbles. Okay, so what is the sample size? What is the total number of possible outcomes here? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 possible marble choices here. Okay, so this says, what is the probability of blue given not white? So, saying that in English terms, what is the probability of selecting a blue marble given that the marble is not white? So the only possibilities, if I'm only looking at this condition that the marbles are not white, that means I'm only looking at the red and blue marbles, because I'm giving you the condition that the marble is not white. So out of the marbles that are not white, what's my total possible set of outcomes? Well, I have 1, 2, 3, 4, 5 red marbles, 1, 2, 3 blue marbles. So there are 8 total possible outcomes of marbles that are not white. So that's my condition. They're not white. Now I'm trying to find the probability of a blue marble. Well, in this group of non-white marbles, there are 3 blue ones. So the probability of selecting a blue marble given the marble is not white is 3 divided by 8. 3 divided by 8 is 0.375, or 37.5%. So with this conditional probability question, I identified the sample space given my condition. My condition was that the marble is not white, so I only looked at the non-white marbles. Determined my sample size. My sample size based on that sample space was 8 marbles, 8 non-white marbles. And the probability of selecting a blue marble in that new set, in that new sample space, was 3 blue out of 8 non-white marbles. 37.5%. Okay, so now I'm trying to find the probability that a marble is not red given that the marble is not white. So the set that I'm looking at, the sample space, is the non-white marbles again, which is out of 8. Right? So there are 8 non-white marbles, and I'm trying to find the probability that I will select a non-red marble out of this sample space. Well, of the marbles that are not white, there are only 3 marbles that are not red. Those blue ones. We're tempted to include these 4 white ones. Well, the white marbles aren't red either. But remember, my condition at the very beginning is I'm only looking at the marbles that aren't white. So of the marbles that aren't white, being the red and the blue ones, the probability of selecting a marble that's not red is only 3 out of a total of 8 marbles. Again, 37.5%. Okay, let's do one more example. This one says a number is randomly selected from a container containing all the integers from 10 to 50. Should write 10 right here. All the integers from 10 to 50. I've written out this sample space such that the gray highlighted numbers are the prime numbers, and then these columns right here are the even numbers. You'll see why that's handy here in just a minute. So right here, this isn't a two-way table. This is just a couple of sets. So I'm trying to find the probability of selecting an even number given that the number is greater than 40. So my condition is that the number is greater than 40. So I'm only looking at these numbers right here. So how many total numbers are there greater than 40? There are 10. So of those 10 numbers greater than 40, I want to find the probability of selecting an even number. Well, there's 1, 2, 3, 4, 5 even numbers that are greater than 40. So the probability of selecting an even number, given that number is greater than 40, is 5 out of 10, or 0.5, or 50%. The probability of selecting an even number greater than 40. Okay, now I'm swapping them. Now I'm finding the probability that I select a number greater than 40, given that the number is even. So let me erase this real quick. Now I'm only looking at my even numbers. So that's these ones, these ones, these ones, these ones, and these ones, and 10. So how many numbers are there that are even? Well, there's 4, 8, 12, 16, 18, 19. There are 19 even numbers. That's my condition. I'm only looking at the even numbers. Now, what is the probability, given that the number is even, that I find a number greater than 40? Well, of these even numbers, the only numbers greater than 40 are 42, 44, 46, 48, and 50. 1, 2, 3, 4, 5. So 5 out of 19. 5 divided by 19 is 0.263, or 26.3%. So this is a good example of conditional probabilities because you see here I have the probability of an even number given that the number is greater than 40. And here I have the probability of selecting a number greater than 40 given that the number is even. They're very similar. The conditions are just switched, but look how much different those probabilities are. So it's important to pay attention to what the condition of a conditional probability is. Okay, you can try out this last one by yourself if you would like, remembering that the gray numbers on here are your prime numbers. But I'm going to go ahead and skip that last one. You can do it on your own. We're going to do a handful of homework problems. So we're about 21 minutes into the video. If you're feeling good, you can go start the homework. I'm going to do this selection of homework problems with you. This is a good opportunity to get some of that homework knocked out. These are problems 10 through 14. So the following table shows the amount of sleep a student got before a test and the performance on the test. Use the table to answer the following questions. So before we look at any of the questions, let's look at this table. So it looks like in my columns I have students who passed the exam, who failed the exam, and then students who got less than 6 hours of sleep and more than 6 hours of sleep. So this is the total column of people who passed the exam, total people who failed the exam. This is the total number of people who got less than 6 hours of sleep, and total people who got more than 6 hours of sleep. Looks like there's 120 total people in this test, in this scenario. Now, let's go answer some conditional probability questions. Some of these will be conditional probability questions. Some of these will be reflective of what we've talked about in past lessons on probability. So here it says, if you select one student, this is number 10, if you select one student at random, what is the probability that you select a student that got less than 6 hours of sleep if they failed the exam? So my condition is that they failed the exam. So it's saying, what is the probability that we select someone that got less than 6 hours of sleep given or if they failed the exam? So I'm only looking at the students who failed the exam because that's my condition. So of those 18 students who failed the exam, what is the probability that I will select a student that got less than 6 hours of sleep? Well, in my failed exam column, I have 10 students who got less than 6 hours of sleep. So 10 out of 18 is the probability of selecting a probability that a student got less than 6 hours of sleep if or given they failed the exam. So 10 divided by 18 is 0.556, or 56%. So given that a student failed the exam, there's a 56% chance that they got 6 hours or less of sleep. Okay, question number 11 says, if you select one student at random, what is the probability that they failed the exam? Okay, well, this isn't a conditional probability. I just want to know, out of all the students, what is the probability that they failed the exam? Well, the total sample space for all my students is 120. There's 120 total students. So what is the probability that they failed the exam? Well, there are 18 total kids who failed the exam. So 18 out of 120 kids failed the exam. 18 divided by 120 is 0.15, or 15%. So notice what they're doing here. The probability just of selecting a student at random and them failing the exam is only 15%. So most of the kids passed the exam. But notice here, if they got less than 6 hours of sleep, only 56% or 56% of them failed. So it's way more likely that you were going to fail if you didn't get enough sleep. That's what we're kind of doing here. Once we find these probabilities, we're kind of trying to analyze what's going on. Is sleep influential on whether you're going to pass an exam? Right now, it's looking like maybe. So that's kind of the point behind some of these probability questions. We're trying to make decisions and test out what's happening and see the effect that certain things have on other things, like here, the effect that sleep has on your performance on a test. Okay, number 12 says, if you select one student at random, what is the probability that you select a student that failed the exam if they got more than 6 hours of sleep? So now let's look. If my condition is that the student got more than 6 hours of sleep, so my condition, I'm only looking at the students who got more than 6 hours of sleep, which is 98. There are 98 students who got more than 6 hours of sleep. What is the probability that I select a student that failed the exam? So of the students who got more than 6 hours of sleep, 8 of them failed the exam. So the probability, 8 divided by 98, is 0.082, or 8.2%. Now look at this. If you got more than 6 hours of sleep, only 8% of the people who got more than 6 hours of sleep failed the exam. Does sleep have an influence on how well you perform on a test? Looks like it probably does. 13 says, if you select one student at random, what is the probability that they got more than 6 hours of sleep? So again, this isn't a conditional probability. It's just saying out of all the students, what is the probability that they got more than 6 hours of sleep? Well, of my 120 students, 98 of them got more than 6 hours of sleep. So 98 divided by 120 is 0.817, or 81.7%. So most of those kids, 81% of them, got more than 6 hours of sleep. So now the last question, this is kind of the real world, so what? So what? Why are we talking about these probabilities? What does it help us determine? So in this study, say this was a study that someone did testing if sleep had an effect on your test scores on an exam. 14 says, do you think getting enough sleep affected performance on the exam? I think yes. From the probabilities that we were able to compute, the conditional probabilities, it looks like of the people that got more than 6 hours of sleep, of the people who got more than 6 hours of sleep, very few of them, only 8.2% of them, failed the exam. But of the people that got less than 6 hours of sleep, it looks like over 50% of them, over half of the people who got less than 6 hours of sleep, failed the exam. So yes, I would say that getting enough sleep does affect your performance on an exam or on a test. So think about it. Next time you're preparing to take the ACT or a final test or whatever it may be, think back to this probability question. So that is it. That's what we're talking about with conditional probabilities. And hopefully you see now kind of the application that it has in the real world with different studies that people do, being able to assess cause and effect and correlation type relationships that you can find using probabilities. So that's the end of this unit. Hopefully now you're able to find a conditional probability using a two-way frequency table, and also find a conditional probability using other sets and subsets like we talked about with the marbles and with the other example that I can't remember off the top of my brain right now that we talked about, the numbers 10 through 50. So I hope that was helpful. Please reach out to me if you have any questions whatsoever, and I hope that you enjoyed that as much as I did.